area of the quadrant is equal to 1/4 of the total area of the circle. 1/4 of what is the total area? Pi r square. Okay. And the next result is, if I want to find out the length of this arc here, you see this length, this curved part. If I want to find out the length of this part, which is called arc AB, area length of the arc AB is equal to, now the circumference of a circle is 2 pi r, and because a quadrant is 1/4 of a circle, therefore this length AB will also be 1/4 of the total circumference, which is equal to half of pi r, or pi r by 2. Okay. And finally, you have the perimeter of a quadrant. Now all these you don't need to remember. If you remember the formula for area of circle and circumference of a circle, you'll be able to do all these on your own. Perimeter of a quadrant is equal to, if you see, perimeter of this is length of this arc here, the curved part, plus this length OA, plus this length OB. These are the boundaries. So you sum up the length of these boundaries, you will get the perimeter. Length of the arc AB plus OA plus OB. Length of the arc AB is half pi r plus OA is r and OB is also r. So you get half of pi r plus 2r. If you take r common here, you get half pi or pi by 2 plus 2. This, you can remember this formula for perimeter if you want. Otherwise, this is not finding out the perimeter of a quadrant is not a tough job, even if you don't remember the formula. Okay. Let's move on to the problem or example that I have given you. Look at this. The perimeter of a sheet of tin in the shape of a quadrant of a circle is 12.5 centimeter. Find its area. The perimeter of this quadrant is given to you. Okay. Let's draw a rough quadrant. It's a rough quadrant. This is a sheet of tin. Okay. Now the perimeter of this tin is given to you. How much is the perimeter given? 12.5. So let us first find out the perimeter of the quadrant just as we did earlier. Okay. If the radius is r, therefore what is the length of the arc AB? One-fourth 2 pi r, which is equal to pi r by 2. Okay. Therefore perimeter of the quadrant, that is equal to length of arc AB plus OA plus OB, just as I showed you earlier, is equal to pi r by 2 plus r, which is equal to pi r by 2 plus 2r. And now you can take r common to get pi by 2 plus 2. Okay, this is the perimeter. What is it given? According to a problem, perimeter is given to be 12.5. So therefore r into pi by 2 plus 2 must be equal to 12.5. From here, we can find out R. If you see, they have asked you to take pi is equal to 22 by 7. So we'll take pi is equal to 22 by 7. R 22 by 7 divided by 2 plus 2 is equal to 12.5. R, and this is 22 by 7 into 2 plus 2 is equal to 12.5. Now you can cancel here 11 times. R, here 11 by 7 plus 2 is equal to 12.5. So now you have R 11 plus, if you take the LCM will be 7. So you get 11 plus 14 is equal to 12.5. 11 plus 14 will give you 25. So this will be 25 R by 7 is equal to 12.5. Cross multiply now. 25 R is equal to 12.5 into 7. That means R is 12.5 into 7 divided by 25, which is equal to 125 into 7 divided by 10 into 25. If you shift the decimal one place to the right, you'll have to divide by 10. So now you can cancel here. You get 7 by 2. Keep it as a fraction because it is easy to work with a fraction. Okay. We're getting R is equal to 7 by 2. Now we have to find out the area of this quadrant. Once from the perimeter of this quadrant, we were able to find out the radius. Now, once we know the radius, we'll be able to find out the area. Hence, area of the quadrant, area of the sheet of 10 in the shape of a quadrant is equal to 1/4 of pi r square. Put the value 1/4. Pi is 22 by 7 into r square, 7 by 2 square. Now you can write this as 1/4 into 22 by 7 into 7 by 2 into 7 by 2. So that this 7 and this 7 will cancel. This will cancel 11 times. So you have 77 by 8, which if you convert to decimal, you get 9.625 centimeter square. And that is the area of the quadrant. Okay, any question here? Now, next, there's a small concept. It's actually been deleted from your syllabus, but I would just mention it once. You will not get any application of this. Okay, but still I'll just mention. If any sector of a circle is given to you, for example, let's say this is our circle and this is the center. Such that this is the sector of a circle. You need to find out the area of this sector. Such that the angle here is, suppose angle here is 72 degrees, suppose. Then what is the area of this sector? Area of sector OAB is 72 degree. And what is the total angle here? What is the total angle here? 360 into what is the total area of a circle? Pi r square. So if you know the radius, you can find out the area of this sector. Okay, that is what it means. So in this case, suppose if instead of 70 degree, if this was 90 degree, this angle was 90 degree, then what would you have called this sector? Anyone? What is the name of this sector? Can you tell me what is the name of this sector?
No, sir.
It becomes a quadrant because 90° means 1/4 of a circle, right? So if this angle is 90°, that means you will have 4 such parts. 90°, 90°, and 90°. So this becomes a quadrant, right? So what is the area of the quadrant? 90 by 360 into pi r square. Now see, are we getting 1/4 pi r square from here? As I had discussed earlier, that quadrant is nothing but if you divide the circle into 4 parts. Understood what I'm trying to say?
Yes, sir.
Now suppose if I have, instead of this, if I have a circle like this, and this is the center. This is the center. Now if I want you to find out the area of this, what is this called? What is this sector called? What is this sector called? It's called a semicircle, isn't it? What is this? What is this angle here? 180°, right? So if you want to find out the area of this sector, which is a semicircle, 180° divided by 360 into pi r square. So we are getting what? This will cancel twice. So we're getting half pi r square, which is the area of a semicircle. You understood?
Yes.
Sector and semicircle. So sector means angle at the center is 180°. That is why half pi r square. And similarly, you can do for the arc also. Okay. Instead of multiplying by pi r square, you can multiply by 2 pi r. Okay.
Sir, can you please scroll the screen a little up?
It's okay.
Yes, sir.
Can I erase this?
Yes, sir.
Oh, I don't need to erase. I'm going to the next part actually. Okay. Exercise problems now. Question number 1. A road 3.5 meter wide surrounds a circular plot whose circumference is 44 meter. Find the cost of paving the road at rupees 50 per meter square. Forget about this for the time being. If you are able to find out the area, then you simply multiply by 50 and you will get the cost. Okay, forget about this. Concentrate on the first part of the question. A road 3.5 meter wide surrounds a circular plot. So you have a circular plot and you have a road surrounding it. Okay, um, surrounding this circular plot. So you have, say, this kind of a road you have around this. Okay, this is your road. So road is in form of what? Road is in the form of a circular ring, isn't it? And which one is your circular plot? This is your circular plot. And this is your road which surrounds it. Okay. A road 3.5 meter wide. Now what is the width of this road? Width is 3.5 meters. Okay. Surrounds a circular plot whose circumference is 44. So what is the, if you see the unshaded circle here, the circumference of this unshaded circle is given to be 44 meters. You understood the problem? So question is, find the cost of paving the road at 50 per meter square. 1 meter square of the road costs rupees 50 to pave. Okay. That means what should be a total cost of paving? You find out the area of the shaded region, that is the area of the road, and then you multiply by 50, you'll get. First priority is to find out the area of the road. So you have to find out the area of the circular ring. But for area of the circular ring, what do you need? You need the inner radius and you need the outer radius, right? But the inner radius is also not given and the outer radius is also not given. instead of the inner and outer radius, what is given to you is the circumference of this unshaded circle. Okay. So circumference of the inner circle is equal to 44 meters given. I say let the inner and outer radius be r and r respectively. Suppose this is your inner radius. Let the inner and outer radius, radii, be r and capital R respectively. Therefore, what is the outer radius? Outer radius is this radius plus width of the road, which is 3.5. You agree? But we
Yes,
don't
sir.
know the inner radius, right? But we don't know the inner radius. So we'll calculate the inner radius, small r, with the help of this information given. Circular plot whose circumference is 44. So circumference of the circular plot is 2 pi r. And according to the problem, what is 2 pi r equal to? 2 pi r is equal to 44. So from here we can find out the radius. Because no value of pi is given, you can take pi is equal to 22/7. Cross multiply. Now divide both sides by 2 into 22. Okay, so how much are you getting here? This cancels 22 times and this cancels once. So you get r is equal to 7 centimeter. You have got the inner radius. So therefore, what is the outer radius? If you add 3.5 to the inner radius, you get the outer radius. Therefore, outer radius capital R, small r plus 3.5. Small r we found above to be 7, which is 10.5 centimeter. So now we have got the value of small r and we have also got the value of capital R. Now can we find out the area of the circular road around it? Therefore, area of the road surrounding the circular plot is equal to pi, area of the ring formula, pi capital R square minus small r square is equal to pi, put the value of capital R 10.5 square, small r is 7 square, which is equal to, put the value of pi as 22/7. And for this, you can calculate 10.5 square and 7 square and put it. Otherwise, better way is you expand this by a plus b into a minus b formula. This is a square minus b square. So a plus b into a minus 22/7 into 10.5 plus 7 is 17.5. And this is, I think 2.5. 10.5 minus 7. Okay. So I think now this will cancel here. 2.5 times. So therefore you are getting this as 137.5 if you multiply meter square. Now 1 meter square costs how much? Rupees 50, right? Cost is given here. 1 meter square costs rupees 50. The cost of paving 1 meter square is rupees 50. Therefore, the cost of paving the road of area 137.5 meter square is 137.5 into 50. Okay. How will you calculate this? You can multiply directly, or one good way of calculating this is you can convert 50 to 100. 137.5 into 50 you have. You multiply this by 2. So 50 into 2 will combine to give you 100. But because there's an extra 2 here, you can divide it by 2 also. Now what you do is numerator becomes 137.5 into 100 divided by 2. So now this becomes 13750. Now it is easy to calculate. So this will become 6,875 rupees. 6,875 rupees to pave the entire road. Is this clear? No question?
No, sir.
No, sir.
Move on to the next problem then. And the next problem is a very interesting problem. And an important one too. No figure is given in this problem. So everything will depend on your understanding. A copper wire, when bent in the form of an equilateral triangle, has area 121 root 3. You know what is a copper wire? If you strip a wire, the electrical wires that you have, if you remove the rubber from the wire, from the wiring of your house, then what you get inside is copper wire. In physics, you must have studied copper is a very good conductor of electricity. That is why you have these copper wire with rubber casings on top. So you strip those wires, you'll get a copper wire. It's bent in the form of an equilateral triangle. So you have this copper wire. Say this is the length. This copper wire, what I do is I bend it and form an equilateral triangle. Okay. Fine. So now this entire length here consists of the sides of this triangle, right? So length of the wire must be equal to what? Can anyone tell me length of the wire must be equal to what? Length of the wire must be equal to what? If I make the copper wire into a triangle, length of the wire must be equal to the perimeter of the triangle, isn't it? Length of the wire must be equal to the perimeter of the triangle. Okay, so we have this understanding. Next is, if the same wire is bent in the form of a circle, the same wire, now what I do is that I, untangle the wire, straighten the wire, and then what I do is I make a circle out of it. So what happens? Now the length of this wire becomes the circumference of this circle, right? So now that we have this idea, now we can start the problem. So this wire, first of all, is bent in the form of an equilateral triangle whose area is given to be 121 root 3 centimeters square. This is the area of this triangle. Okay. So if A be the sides of this triangle, what is the area of triangle ABC? Is equal to root 3 by 4 A square. Right? How much is the area given here? 121 root 3 is equal to root 3 by 4 A square. We can find out A from here. That is, we can find out each side of the triangle. So you cross multiply. 121 root 3 into 4 is equal to root 3 A square. That means A square is 121 root 3 into 4 divided by root 3. This cancels. So you get A square is equal to 121 into 4. Okay, now what you can do is you can multiply also. I'll give you a better way also. But ordinarily what you have a tendency of doing is, so 121 into 4 you have. So you multiply these two to get 484. Okay. And then what you do is you take the square root of 484. You know division method of finding square roots? You can find out the square root of this by division method as 22 centimeter. You have found out the side. Now, but however, I recommend a better method of instead of finding the square root, after this a square is equal to 121 into 4. What you can do is, because you know that 121 is a perfect square, so you can write 121 as 11 square, and you can write 4 as 2 square. So that means a square is 11 into 2 whole square. Okay. That means a is square root of 11 into 2 square, which is equal to 11 into 2, which is equal to 22 centimeter. Okay. I've got the sides of the equilateral triangle. So if you remember, I told you the length of this wire, because we are making this triangle out of this wire, the length of this wire must be equal to the perimeter of this triangle, right? So what is the length of the wire? Is equal to perimeter of triangle ABC. Is equal to 3 into A, right? That is the perimeter of an equilateral triangle, which is equal to 66 centimeter. So the actual length of the copper wire was 66 centimeter. Now what is being done is, with this copper wire has length 66 centimeter. We have already got this. Now this copper wire, I am straightening up, and now I am bending it in the form of this circle. Okay, now if I, in the beginning I told you, if I'm now making a circle, then the length of this wire must be equal to the circumference of this circle, right? So if the wire is bent, if the wire is now bent to form a circle, length of the wire must be equal to circumference of the circle is equal to 66 centimeter. The circumference of the circle is 66 centimeter. Can we find out the radius of the circle? Yes. Therefore, 2 pi r must be equal to 66 centimeter. Problem number 1 that I did, if you remember, if you know the circumference of the circle, you can find out the area of the circle. But before finding out the area, you need to know the radius. So with the help of the circumference, we'll find out the radius. Put the value of pi as 22 by 7, because nothing is given. You can take pi as 22 by 7. Now you cross multiply. Now you divide both sides by 2 into 22. Okay, so this will cancel 33 times. Now you can cancel with 11. So you get 7 by 2 centimeter. Keep it as a fraction because we need to work with this. So you have got the radius. And what is the question here? The question here is, find the area enclosed by the wire if it is bent in the form of a circle. So I found out the radius of this circle. How much have we found out the radius? 7 by 2 centimeter. So now what should be the area? Pi r square. Put the value of pi, 22 by 7 into r square. Okay. 77 by 2 centimeter square. And this you can convert to decimals, 38.5 centimeter square. That is the required area. Okay.